Hello guys, how are you today? So today I'm gonna be explaining the level T and term 1 final quiz, which is found in the AP classroom. Okay, so I submitted anything, I'm gonna get the answers. And what I'm gonna do is I'm gonna read the questions, look at the answers, and we're gonna see how we need to answer this question if it came as a written part. So in question 1, it says, a student wishes to determine the concentration of Ag plus aqueous in a solution of AgNO3 aqueous. The student combines 10 milliliters of AgNO3 aqueous with excess Na2SO4 aqueous and observes the formation of a white precipitate. The formation of the precipitate is represented by the following equation. They want the balanced net ionic equation. Whenever they talk to us about net ionic equation, we directly remove anything aqueous. That means the only two that are going to be acting is Ag and SO4. So you will remove NO3 and you will remove Na2. So what will it be? It will be 2 Ag. Hold on. 2 Ag plus, because you always take the charge, so Ag plus aqueous plus SO4. 2 minus aqueous will give me Ag2 SO4 solid. So you write this and you will get what? You will get your mark. If you look over here, you will see they said what? They said 2Ag plus aqueous plus SO4 2 minus aqueous will give me Ag2 SO4 solid. We'll move on to part B. The student collects the precipitate by filtration and measures the mass of the filter paper and precipitate every 10 minutes as it dries. The student records the data in the following table. Use the data above to calculate the number of moles Ag2SO4 solid. Okay, knowing that the molar mass is 311.8 grams per mole that precipitated. So, they told us, the student, what did he do? He kept on heating and filtering until he got what? He got the mass of the filter paper and the precipitate after 30 minutes, right? Now from this, he got the very last mass, which is after 30 minutes, to be 3.79 grams. So is this the mass of Ag2SO4? No, it's wrong. Why? Because it's supposed to be the mass of the filter paper and Ag2SO4. So it's the mass of the filter paper and the precipitate. But we need to get rid of what? We need to get rid of the filter paper. If you go up, you will see that they gave us the mass of the filter paper, which is 0.88 grams. So I will take the mass of the filter paper and the precipitate, which is 3.79 grams, and I will subtract from it the mass of the dry filter paper, which is 0.88 grams, and I will get my answer to. It will give me, to the correct number of decimal places, 2.91 grams. How did I know it's to the correct number of decimal places? Here it ends with 2 decimal places, it ends with 2, and it ends with 2 over here. So the mass of the precipitate Ag2SO4 is how much? Is 2.91 grams. Now we can find the number of moles, because we know that number of moles is equal to the mass over the molar mass. So it's 2.91 grams over 311.8 grams per mole. What will I get what will I get as my answer? I will get as my answer 0.00933 moles. Of course, to the correct number of significant figures, because this is 3 and this is 4. For sure, I'm taking the less, which is 3. So I'm going to have 3 significant figures, okay? So in part B, in order to get the full answer, first thing you're supposed to write is this. Second thing is you're supposed to write is this, and you're going to get 0.00933 moles of Ag2SO4. We'll move on now to part C. What does it say in part C? Calculate the concentration of Ag plus in the original 10 milliliter solution of AgNO3 aqueous. So, they want the concentration of Ag plus. Concentration of Ag plus would be the number of moles of Ag plus over what? Over the total volume, right? So how do I find the number of moles of Ag plus? I found the number of moles above for Ag2SO4 to be how much? To be 0.00933 moles. Now, if I split them into their ions, I will have Ag plus and SO4 2 minus, and I will have 1 over here and 2 over here. So my ratio is gonna be what? It's gonna be 2 to 1, where Ag plus is 2 and SO4 minus is 1, right? So that means if 1 Ag2SO4 gave me 0.00933, then how much will 2 Ag plus give me? It will give me 2 times 0.09, I forgot the 0.00933 moles, right? So 2 times 0.00933 moles. So I will get my answer to be 0.0187 to the correct number of significant figures, which is how much? Which is 3. So 0.0187, how much? Moles. Now this is for what? For Ag plus. I have the number of moles of Ag plus. I can find the concentration now. 0.0187 moles. Over the volume, you will divide it by 1,000 because it needs to be in liters, okay? So 0.0187 over 10 divided by 1,000, and I will get my answer to be what? To be 1.87 molarity. So the concentration is 1.87. If we check the answer key, we would get 1 entire point for writing this, okay? And then for writing this. We'll move on to part D. What does it say in part D? So, part D. The concentration of Ag plus aqueous determined by the student is significantly higher than the actual concentration of Ag plus. Based on the student's data table, identify an error. So if you go up, you're going to see that the student, I don't know, he was heating or he was letting it dry. No, he was letting it dry. So the student was letting it dry, right? However, when you see, when you look at the results, you see it's always decreasing, and it never reaches a constant mass. So because it never reaches a constant mass, okay, that means maybe the water did not entirely dry out. Unless it reaches a constant mass, then our solution is gonna always be what? It's gonna have a greater number of moles. However, if he let it dry more until he kept on getting a constant mass, then he would ensure what? He would ensure that his answer would be correct. So the response provided gives a source of error. What's the source of error? The student did not wait for the precipitate to dry completely, and he did not reach a constant mass. That's it for question number 1. We'll move on to question number 2. A new element with atomic number 116 was discovered in 2000. Okay, so basically it's so much talking. Let's look at the first question. A. Write the electron configuration for the valence electrons of LV in the ground state. Now notice here what they said. They want the electron configuration for the valence electrons. So I'm going to open my periodic table. Let's find my periodic table. My bad. So this is my periodic table, and what was, let me go back, my bad, whoops. Okay, let me go back to the AP classroom. What is my element? My element is LV, which is livermorium. So I'm gonna go back to my periodic table. I will find LV, it's over here. It has what? It has, okay, this is giving me what? It's giving me the isotopes. I don't want the isotopes. Let me go to compounds, okay? So it has what? Okay, so I will find LV, livermorium, okay? Livermorium, and I will see that the atomic number is 116, but I can also see that it is in which group? It's in group 6, period 7. Now something you need to know is always for group 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8, in order to find out the valence shell configuration, you just need to do what? You just need to do the configuration of the toppest element on the group. For example, we want to do group 6. I will take oxygen. I will do, what's the electron configuration of oxygen? Of oxygen, it's 1s2, 2s2, 2p4. Now, I know that in oxygen, my valence shell is the last shell, which is 2s2p. This is the shell that contains my valence electrons. So what I'm gonna do now is I'm gonna remove the 2, okay, and I will make it as an N. And now, this is what? This is for, in general, for group 6, this is how the valence electron shell looks like. So, it now depends on what? It depends on the period. So, period 2, that means this is 2s2 to p4. period 7. That means this would be 7s2, 7p4. Okay, that means my answer, if I go back to the AP classroom, my answer is supposed to be 7s2, 7p4. Okay, now, for question B, according to the periodic properties, what would most likely be the formula for the product obtained when LV reacts with H2? Now, LV is a nonmetal, H2 is a nonmetal. Together, they will form covalent bonds. So, in the AP that we're doing now, we don't need to know in which order do we put it, but logically speaking, in the group you have H2O, H2S, H2SE. So logically speaking, it would be preferable to write it as H2LV. Now, how did I know it's H2LV? Because first of all, everything in the group is like this. That means for sure it's gonna end up like this. And if I did the charge, it would be LV2 plus and LV2 minus and then H plus. And then I would do the crisscross method and I would get what? I would get H2LV. Okay, so part B is my answer. So it's either H2LV or LVH2. You can write it either way because we're not supposed to know how to write it, but it's preferable to write it as H2LV. Part C, the first ionization energy of polonium, PO, is 812 kilojoules per mole. Is the first ionization energy of LV expected to be greater than, less than, or equal to that of PO? So we go back to my periodic table here. LV is here, PO is on top. So what can we say about this? First of all, we know that as we go down the group, what happens to the ionization energy? The ionization energy decreases. So first thing I'm going to do is I'm going to go back. Where's my AP classroom here? I'm going to go back and I'm going to say what? I'm going to say that PO is higher than LV in the periodic table. Okay. From this, I can state what? that LV has a less than or a less ionization energy than polonium. Now, after I state this is my statement, I need to resort to what? I need to resort to my explanation. So I just finished the first part of the question, which is to identify and state, okay? Now it's to explain my answer. Why is LV ionization energy less than that of polonium? Using what? Using Coulomb's law. Now, if we look at the answer key, this is exactly how they want us to say it. The two atoms have comparable effective nuclear charges, but the valence electrons in LV would be at a greater distance from the nucleus than those in PO. By Coulomb's law, the attractive forces between the valence electrons and the nucleus decreases by the inverse square of the distance between them. So, what they are basically saying here, they're saying that although nuclear charge increases, okay, of course you need to write increases, not the arrow up, you need to write increases. Okay, so let me just write that. Although nuclear charge increases, okay, we say, but also the shielding effect and core electrons, what happens to them? They also increase as well. Due to this, valence electrons are at a greater distance from the nucleus, from the nucleus than those in PO. My bad, I accidentally removed the pen. But anyways, we can say basically after all that we wrote, okay, according to Coulomb's law, Coulomb the greater the square of the distance, or how they said it in a better form, according to Coulomb's law, the attractive force, which is the ionization energy, the attractive force decreases between the valence electrons and the nucleus by what? By the inverse square of the distance between them. Okay, so if you say all of this, which is very important to say, you will get what? You will get the full mark. So that is part C. We'll now move on to part D. It says, shown below is a hypothetical mass spectrum for a sample of LV containing 10 atoms. This is very important. They told us use the information in the graph to determine the average atomic mass. Whenever they say average atomic mass, you need to write AMU. If they said relative atomic mass, you don't need to write AMU. It does not exist in relative atomic mass, but average atomic mass, it does exist. So we start with like any regular solving equation, okay? So I will take what? I will take the number of atoms, which is 2, multiplied by what? By the atomic mass, which is 291.2. I will add it to what? I will add it to the number of atoms, which is how much? Which is 3, multiplied by the atomic mass, which is 292.2, and I will add it to what? I will add it to 5, okay? Multiplied by what? Multiplied by the atomic mass, 293.2. Now, in the average atomic mass, usually they give us percentage. Here they did not give us percentage. Instead, they gave us the number of atoms. So you add them all together and you will get 10. And in all scenarios, they give it to us on top as 10. So 2 times 291.2 plus 3 times 292.2 plus 5 times 293.2. All of this over 10. And you will get your answer to be 292.5 AMU. You're supposed to add the AMU because it's average atomic mass. So my answer is 292.5 AMU. That's it for question number 3. We'll move on. That's it for question number 2. We'll move on to question number 3. Now, usually you've got to read the question for chemistry, okay, before answering. So write the complete ground state. Ground state means it's not excited. Electron configuration of the Kr atom. Kr, let us go to the periodic table. My periodic table, I'm looking for what? So let me choose it over here. Okay, so what are we looking for? We're looking for krypton over here. Krypton is a noble gas. So how do I write the ground state configuration of krypton? Very simply, I take the noble gas before it, which is argon. And then what do I put? I put the termination, okay? So how do I find the termination? Very simply, I can just find the valence electrons of neon. So what is neon? It's going to be 1s2, 2s2, 2p6. Oh, but actually I cannot apply this to the noble gases. It's not going to work. So instead what I'm going to do is I'm going to see the regular configuration of krypton. So it's going to be 1s2, 2s2, 2p6, 3s2, 3p6. So in total, this is how much? 4s2, 20, 3d10, 30, and then 4p6, this is how much? 36, this is krypton. So I removed 18. How much is 18? This is 10. This is 18. So that means what should I be left with? What should I put after argon? I should put 4s2, 3d10, 4p6. So this is how I write the ground state configuration for krypton. So you could either write it like this or argon 4s2, 3d10, 4p6. We move on to part B. What does it say? It says the Rb plus ion has the same electron configuration as the neutral Kr atom. So what does this mean? This means they have the same number of electrons. Okay, which has the larger radius, Rb plus or Kr? Now we need to think, because they have the same number of electrons, we need to think in terms of atomic number. I will look for Rb plus. Rb plus has 37 protons, whereas, so this is Rb plus, whereas krypton has 36 protons. So on the same number of electrons, to be more specific, the same number of valence electrons, 37 protons is acting versus 36 protons is acting. For sure, this is gonna be what? This is gonna be a stronger force of attraction because charge increases, or quantity of charge, because the quantity of Yeah, my bad. Because the quantity of charge increases, so we say that Rb plus will have a stronger force of attraction because the quantity of charge increases. So according to Coulomb's law, what happens to my distance? The square distance decreases. Right? So what does this mean? This means rubidium is going to have a smaller atomic radius. So thus we can say Kr will have the larger atomic radius. And this is all answered in terms of Coulomb's law. Let us see what they want us to answer. They want us to see that the outermost electrons of Kr occupy the same shell as Rb+, but Kr has one less proton, resulting in a weaker Coulombic attraction between the Kr nucleus and its electrons. Therefore, Kr has a larger radius than Rb+. Okay. Now, in part C, what did they tell us? The composition of a sample of solid Rb containing a high percentage of the radioactive isotope Rb83 is given in the following table. So using the values in the table, calculate the average atomic mass. Again, they said average atomic mass. That means I'm going to be using AMU. Unless they say relative atomic mass, then I won't use AMU. Now, let us calculate the average atomic mass. It's going to be the mass multiplied by the percentage, right? So 82.92 times the percentage, which is 32.5%. Plus 84.91 times 50.8%. Plus 86.91 times 16.7%. Now, you add them all together, you will get what you will get, the average atomic mass to be 84.6 AMU. So let us check the answer key. The answer key is 84.6 AMU. They did it as well in what they did it as well, in the same method. We'll move on to part D. We don't have part 2. We don't have part 2 of question 3C. So we finished question 3C. We'll move on to question 4. Okay, what does it say in question 4? For parts of the blah blah blah, okay, we read the actual question. A student has 10 gram sample of CaBr2. Show the setup of the calculation to determine the number of moles. This is very easy. You can say number of moles equals mass over molar mass. So it's going to be 10 over the molar mass of CaBr2. Ca has a molar mass of 40. So 40 plus Br has a molar mass of 79.9, so basically 80. So 40 plus 80 times 2, that's going to be 200. So it's going to be... Actually, they didn't take it as 80. They took it as 79.9. So let's take it as 79.9. So anyways, it's going to be 10 over 199.8. Of course, they're going to provide you with a periodic table in the exam. Please use the exact value. So let me actually try using the exact value of my periodic table. Let me go to the periodic table here. PT. I will see what? I will see that bromine has a mass of what? It has a mass of 79.904 grams. And calcium has a mass of almost 40 grams. So, okay, so I'm gonna go back to my classroom, AP classroom, okay? So they took, where's my calculator? They took Ca as 40, and they took Br as what? As 79.904 times 2. Okay, 40. I'm trying to figure out how they got 199.88. Okay, there we go. So you need to take the exact values. So look how they took Ca. They took Ca as 40.078 plus 79. They took Br as 79.904. The exact values multiplied by what? Multiplied by 2. And then you will get 199.88. It should be 89, but they took it as what? They took it as 88. Okay, so now it would be, my bad. What would it be? It would be mass over molar mass. This is the number of moles. So it's gonna be 10 over 199.88 grams per mole. Oh, but it's necessary to state what grams per mole we are using. It's 199.88 grams of CaBr2 per mole, and this is 10.0 grams of CaBr2. So you need to be very specific in the exam. To get the mark, you should write what? You should write. This is like, it seems easy, but there's so many tricks. 10.0 grams of CaBr2 over 199.88 grams of CaBr2 per mole. You will get what? You will get the number of moles N. In part B, what number, in addition to the answer to part A, is needed to determine the number of atoms of Ca? So, basically, they want an additional information needed to determine the number of atoms. Number of atoms is equal to what? Is equal to the number of moles times what? Times Avogadro's number. Okay, so basically what we need is the number of moles, which we have on top, times what? Times what's the information missing? Avogadro's number. So you can write Avogadro's number, right? What did they say? They said the response gives the term Avogadro's number. So you can say we need Avogadro's number. Okay, and his number is 6.022 times 10 to the power of 23. In order to find the number of atoms of Ca in the sample. Now, a different student is given a 10.0 gram sample labeled CaBr2 that may contain an inert non-reacting impurity. Identify a quantity from the result of laboratory analysis that the student could use to determine whether the sample was pure. Okay, in order to determine the purity of a sample, we could use the mass of both Ca and the mass of Br2. So you need to write both of these together, either this or the number of moles of Ca and the number of moles of Br2. This will help us identify them, right? It will help us identify if we have anything added that's an impurity, right? So anyways, how do we know if we have more than one answer? If you click on the mass of Ca, you will also click the mass of Br, so both of them need to be added together. Number of moles of Ca is also what? Is also, you're going to take the number of moles of Br2 in the sample, and then if you could also choose the mass or number of moles of another element than Ca or Br in the sample. Now, part D, explain why CaCl2 is likely to have properties similar to those of CaBr2. Because they are in the same group, meaning they will have the same number of valent electrons. Anyways, let's read their answer. The response indicates that Cl is in the same group as Br, because if you open the periodic table, you'll see that Cl is in the same group as Br. So, thus, it will have the same number of valence electrons, such as a Br atom, and it will have similar chemical properties. That's it for question number 4. We'll move on to question number 5. Okay, so usually in the question, they will tell us how they want to explain it. Using what? Using the principles of atomic structure, explain why the first ionization energy of PO is less than that of SE. If we go to the periodic table, I'm looking for what? I'm looking for PO. Where is PO? PO, where is it? Okay, I found PO over here, and SE, selenium, not AS, my bad, SE, selenium. So they want us to compare using what? Using the principles of atomic structure, why the first ionization energy of PO is less than that of SE. First of all, we know that PO and SE are in the same group. Now, although they are in the same group and atomic number increases, so first thing we say is although nuclear charge or atomic number increases, PO has a greater shielding effect and core electrons than SE, okay? Thus, what can we say? Thus, PO valence electrons are at a greater distance than Se valence electrons. Now let's see what they wrote. They said the average distance between valence electrons on the nucleus is greater in PO than Se because PO has more occupied shells. The valence electrons experience a weaker attraction to the nucleus. Oh, I forgot to mention, so everything that I wrote, I forgot to mention this important part, that the valence electrons experience a weaker attraction to the nucleus in PO than in Se, therefore it requires less energy to remove an electron from PO than Se. We'll move on to part B. What does it say in part B? In part B it says, photoelectron spectroscopy data for 1s sublevel of Se and 1s sublevel of PO are presented below. In terms of Coulomb's law and atomic structure, explain why the peak for PO is positioned so far to the left of the peak for Se. So if we go to part B to see the answer, what does it say? It says the attraction between 1s electron and nucleus is stronger in PO than in Se because PO has 84 electrons, whereas Se only has what? It only has 34 electrons. So they started first of all by describing whatever they saw. They saw that the binding energy or the attraction between the electrons of the 1s, okay? So we're dealing with 1s, we're talking about 1s. The attraction of the 1s electrons for both Se and PO is supposed to be at the same distance. However, because PO has a greater number of protons, what will it exert? It will exert a greater force of attraction. So this greater force of attraction will pull the 1s electrons more strongly. Thus, it requires more energy to break free. So, according to Coulomb's law, the attractive force is stronger when the magnitude of the charges of the particles is greater. Consequently, the 1s electrons in PO are more strongly attracted to the nucleus. So, of course, you have to mention Coulomb's law, right? Which states that the stronger the magnitude of the charges, means the greater number of protons, okay? The greater or more strongly attracted it is to, or like the more strongly it attracts the valence electrons. We'll move on to part C. What does it say in part C? Which structure, A, B, or C, minimizes the formal charges for each atom in SeO2, F2? Now, first of all, you have to see the formal charges in each and every one of them. Now, what do they want? They want SeO2, F2. So directly we can cancel out what? We can cancel out this one. Now we need to play an important trick, which is what? Which is we take the group number of the central atom, okay, Se, which is group 6, and we will subtract from it what? We will subtract from it the surrounding electrons, right? So I'll start with the first one. For Se, I have 6 minus the surrounding electrons, 1, 2, 3, 4, 5, and 6. So it's 0. Then here, 6 minus 1, 2, 3, 4, 5, 1. 6 minus 4, 2. And here it's 6 minus 1, 2, 3, 4, 5, and 6, so it's 0. That means we directly eliminate everything that does not have the central atom to be what? To be 0. So now we're left with A and with D as two possible answer choices. Now, looking at both of them, I can see directly that this one is wrong. Why? Because my compound is SeO2F2. This is SeOF2. I don't have the second O, so directly I consider this to be wrong. And so then I'm left with my only option being what? Being A. Now, let's check. Hopefully the answer is A and I didn't spend all of this for nothing. Yes, correct. Structure A minimizes formal charge because it's the only structure in which the formal charge of every atom is 0. Okay, so perfect. If you check all of the other surrounding atoms, you will see that they're not 0 except in A. All other surrounding atoms are what? Are 0. We'll move on to part D. A student proposes that the energy of the Se to O bond in the structure in diagram D is greater than that of the Se to O bond in structure in diagram C. Do you agree or disagree? If you go here, you will see in diagram C versus diagram D. Diagram C, they are single bonds, whereas in diagram D, they are double bonds. And he's saying what? He's saying, oops, I went up. He's saying that the energy in diagram D, which is the what? The double bond, is greater than the energy in the single bond. Now, yes, this is true. I agree. Why is it true? Because the SeO bond in, let's read the answer, my bad. The SeO bond in structure D is a double bond. Okay, double bond requires more energy to break. Whereas SeO bond in structure C is a single bond. Single bond requires less energy to break. We'll move on now to question number E. they told us that the dipole moment of SeO2F2 molecule is non-zero. Identify its molecular geometry and explain how its geometry and polarity of its bond results in a non-zero dipole. So let's go up. They said A, B, and C. Now, A, B, and C, all of them possess the same structure, which is what? Which is a tetrahedral AX4 structure. How do I know? Because this is AX, X, 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 AX4. AX, X, 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 AX4. AX, X, X, and X, AX4. Now, however, they said that there is a net dipole moment, meaning that it's a non-zero net dipole moment, meaning that it is polar. Why is it polar? Even though AX4, which is a tetrahedral, is a what? Is a symmetrical structure, we have the surrounding atoms are different and they exert different polarity, right? So we can say surrounding atoms are different. So thus they exert what? They exert a different polarity. If we go to the option answer of E, the molecular geometry is a tetrahedral. The SeO and SeF bond dipoles are different in magnitude and cannot cancel this given geometric arrangement, okay? So you can say the SeO and SeF, or in other terms, the surrounding atoms have different magnitude of dipoles and cannot cancel this given arrangement, or this geometric arrangement. We'll now move on to part F. What does it say? What does it say? Identify the types of intermolecular forces that the two substances have in common. What are these two substances? SeOF2 and SOF2. They said that the melting point of SeOF2 is greater. So let us go up, okay? We come over here. And then what do I have? I have SeOF2, SOF2. We start, first of all, by identifying what type of molecules they are. They are molecular covalent, because they form covalent bond, not metallic, not ionic, okay? Next step, we identify. We start with the three different types of forces: H bond, dipole, dipole, and what? And the London dispersion forces, okay? Now, looking at the H bond, we need to look at the surrounding atoms that can form an H bond, and these are fluorine, oxygen, nitrogen. We have fluorine and we have oxygen in both of them. However, because they are not already bonded to hydrogen, they cannot form what? They cannot form a hydrogen bond. So they need to be already bonded to hydrogen in order for them to form a what? In order for them to form a hydrogen bond. So we can say that they don't form hydrogen bonds. Next thing, we take their shape. This is AX3E, and this is also AX3E. Now, these are non-symmetrical. What does it mean if they're non-symmetrical? It means they're polar, and if they're polar, that means what type of forces do they have? They have dipole-dipole forces. So they have dipole-dipole forces, and of course they have LDF forces. So our response should state that both substances have London dispersion forces, and it should state that both substances have dipole-dipole attraction. Is this what they asked us? Yeah, they told us to identify the types of intermolecular forces that the two substances have in common. Now, part G. Explain the difference in melting points based on the types and the relative strengths of intermolecular forces. Now, difference of melting point mainly depends on the LDF, okay? But in the AP, they gave us two ways to say this. You could either compare it based on the LDF, or you could compare it based on the what? You could compare it based on the dipole. So SeOF2, they're saying SeOF2, if you check in the periodic table, you'll see it's sulfur than Se. That means Se has a greater number of nuclear charge, meaning a greater number of electrons, right? So SeOF2 has a larger, more polarizable electron cloud due to the greater number of electrons in Se. And this will lead us to stronger London dispersion forces. So, first thing we state, it has a larger, more polarizable electron cloud due to the greater number of electrons in Se. This will lead to stronger London dispersion forces. Thus, the attractions between SeOF2 molecules are stronger due to the stronger LDF forces than those between the SOF2 molecules, resulting in a higher melting point. Now, this is if you take into consideration what? If you take into consideration the the London dispersion forces. And then if we're checking the electronegativity, I don't know if they will give us the periodic table with the electronegativity because we don't need to memorize them. In Sabas, we don't need to memorize them. But they're saying in SeOF2, okay, the bonds are more polar. Why is that? Because Se and oxygen and fluorine, the difference has a great electronegativity difference, right? Whereas S and oxygen and fluorine is less. Like it has a less electronegativity difference than Se, right? So due to this, the attraction of the dipole are gonna be stronger in SeOF2. Thus, it's gonna happen what? It's gonna happen that the molecules are stronger, okay? The SeOF2 due to the stronger dipole attractions. Okay, so thus we will result in a higher melting point. But I always prefer to come to this conclusion before coming to this conclusion, okay? Why? Because there's always gonna be LDF forces, and LDF forces mainly control the melting points. So now we'll move on to part H. SeOF2 reacts with SiO2 to produce SeO2 and SiF4, the unbalanced chemical equation below. So basically, they want us to balance the equation. How do we balance the equation? We start. I have Se over here, OF, right? Actually, I think I need this whole space. SeOF, right? And I also have Si. Then over here, what do I have? I have SeOF, Si. So, Se will have, we have one Se, we have one oxygen, we have two fluorine, we have one Si, and you put a comma, we have two oxygen. For this one over here, we have one Se, two oxygen, four fluorine, and one Si. So we don't start with the oxygen, we leave it for last because it's in more than one place, okay? But now I come here, I come to F. How do I make 2F? How do I make it become 4? I just need to multiply it by 2. So if I multiply here by 2, what will happen? I'll multiply everything by 2, that means. So it's going to be 2 times 2, which is 4, right? So 2 times 2 is 4. 1 times 2, which is 2. And then 1 times 2, which is what? Which is 2. So now, what changes? Or what changed? My Se changed. Since my Se changed, I will need to change it on the other side as well. So I will put a 2 over here. So now what do I have? I have 2, right? And then 2 times 2 will give me 4. And just like that, it's balanced. I have 2 with 2, 4 with 4, 4 with 4, and 1 with 1. That means it's 2 SeOF2, 1 SiO2, 2 SeO2, and 1 SiF4. So 2, 1, 2, 1. We'll move on to question number 6, and I think this is the last question I'm going to be explaining for this video. So I'll split it into 3 videos, okay? I will have part 1, part 2, part 3. Each video I'll do 6 questions. So they said, to spectrophotometrically determine the mass percent of cobalt in an ore containing cobalt and some inert materials, solutions known as concentration CO2 plus are prepared, right? And the absorbance of each of the solutions is measured at wavelength of optimum absorbance. The data are used to create the calibration plot shown below. Okay, a 0.630 gram sample of the ore is completely dissolved in concentrated HNO3 aqueous. The mixture is diluted with water to a final volume of 50 milliliters. Assume that all the cobalt in the ore sample is converted to CO2 plus aqueous. So they told us that what is the CO2 plus concentration if the absorbance of a sample is 0.74? So what do I need to do? I need to go to the graph. I will say 0.74. This is 0.7. This is 0.8. 0.74 is here, almost. So I'll draw this straight line, and I will reach here, and I will drop down, and I will come to this value over here. What's this value? 0.01, 0.02, no, 0.012. No, 0.011, 0.012, 0.013, 0.014, 0.015. So this is 0.013 molarity of CO. Right? But we need to put it to the correct number of significant figures, which is 3. I don't determine it from the graph, I determine it from here. So it is 3, right? So that means for part A, my answer is going to be 0.0130 molarity. Okay, now we'll move on to part B. Calculate the number of moles of CO2 plus in the 50 milliliter solution. Again, what's the equation? Number of moles is equal to concentration times volume, right? So did they do that? Yes, they did that. They changed the milliliters into liters by dividing by 1,000, so 50 over 1,000, multiplied by the concentration. What's the concentration? Concentration is 0.0130, okay? So what will it give me? It will give me, oh, my calculator, where's my calculator? So it will give me my answer to the correct significant figures, which is 3. This will give me 6.50 times 10 to the power of minus 4 moles of CO2 plus. So that's part B. Now I'll move on to part C. Calculate the mass percent of CO in the 0.630 gram sample of the ore. So what I can do now is I can find the mass of CO2 plus. I have the number of moles and I can find the molar mass. What's the molar mass of CO? It's 58.933. So it's gonna be 6.50 times 10 to the power of minus 4 times, how much is it? 58.933, so times 58.933, 6.50 times 10 to the power of minus 4 times 58.933. This will give me my answer to be 0.0383065, but we take it to the correct, wait, 0.038306, okay. We take it to the correct significant figures, which is the smallest, which is 3, so 1, 2, 3. So I can change it to 0.0383 grams. Now I will put it over the total mass, which is 0.630 grams, right? So it's gonna be 0.0383 grams over 0.630 grams, and then don't forget to multiply it by 100 to get the percent. Now, of course, we need to take it to the correct significant figures, which is 3. So it's gonna be 6.08%. I hope I'm correct. And yes, it's 6.08%. So that's it for this video. I'll continue the rest in the next videos. Thank you guys for watching. I hope you enjoyed and have a wonderful